when we're writing the names of formulas, or writing the chemical formulas, not the names of them, it applies to both the names and the formulas. Cations are written first, so sodium, which is the cation, because it's a positive charge, has a positive charge, is written before the chloride ion. It's an anion, and that's why we get NaCl. Cr2 plus is written before F negative, anion, cation, and the result is we get CrF sub 2 to make it all work out. Okay? And the homework, you had calcium 2 plus and chlorine 1 negative, and you get CaCl2. So the cation is always written first, okay? So this is the cation here, this is the cation here, this is the cation here. All the cations come first. But that doesn't tell us what order we write the element symbols when we have a covalent compound, because covalent compounds don't actually have charges. They are sharing electrons, so there's no way to get a charge, you give up electrons or gain electrons, and so there are no charges really in a covalent compound, at least in this simple way we're thinking about it. So for covalent compounds, we need a different rule. For covalent compounds, the element symbols are written in order of least electronegative to greatest electronegative. All right, I warned you at the beginning of the semester that chemistry is cumulative, and this goes back to Unit 2. We had periodic tables, like 7 of them. We talked about patterns on the periodic table and talked about regions of the periodic table. And one of the things we talked about was electronegativity. Okay? So where do you find the most electronegative elements on the periodic table? Don't remember? Look it up. Up here. Okay, good. Up here, she says. Top right. Except for no, not hydrogen. Noble gases. Okay? You should look this up for yourself. So here's my outline. Cheap and quick outline of the periodic table. Okay? So for electronegativity, we presume the noble gases don't have any electronegativity. A couple of them have some really small electronegativities. We just basically ignore those. Okay? So the pattern is the greatest electronegativity is up here, and the least is down here. So low here, high here. Okay? So then, looking on your periodic table and figuring out where these elements are located. Yes, we're talking about how to name and write the formulas for covalent compounds. Which element do you write first in the formula is what I'm asking about. Okay? So let's say we did phosphorus and chloride yesterday. Phosphorus and chlorine. Okay, remember that? Got to share electrons. Got an electron dot formula. We're going to share electrons now. No, it's the most electronegative.
They're on the same level, but
Okay? It's diagonal of a sort. Upper right, lower left. The ones down here are more in this direction, come first. Got that? Okay. So here's the sharing arrangement, starting with electron dot notation. Now we're going to share electrons, and then we can put together our Lewis dot formula. Okay, guys, if you're chatting about something else, you deserve the grade you get on the test. So when we write the formula for this, because phosphorus is more in this direction, it comes first, because the more electronegative stuff is down here. The greatest electronegativity is up here, those come last. Okay? So the formula is PCl3. No, because sometimes it's above and below. Let's say I was putting together oxygen and sulfur. So since it's like this, which one do you write first? Sulfur. It's more in this direction than oxygen is.
They're kind of like right there.
Yeah, but there's diagonal like this.
From S to...
S is less electronegative than oxygen is. Yes. What? Well, those won't covalently bond anyway, so it wouldn't matter. Lithium's a metal, radon's a non-metal, they don't covalently bond. I mean, they don't ionically bond. Metals and non-metals tend to form ionic compounds. Metals and non-metals tend to bond together in ionic compounds. Not always, most of the time. Metals and non-metals tend to bond together in ionic compounds. We've gone over that in this class. It's also a review from your physical science classes. Okay, you're supposed to know that from physical science, that metals bonding with nonmetals tend to form ionic compounds. Nonmetals bonding with nonmetals tend to form covalent compounds. You're supposed to know that already. Okay? Not that you always remember it, but it should be a review. Okay? Alright, so that's how we figure out which atom or element symbol to write first in the formula. Does that make sense? So ionic compounds, the cations come first. You got to figure out if you got an ionic compound or a covalent compound. Simple ionic compounds are metals bonded to nonmetals. Calcium's a metal, chlorine's a nonmetal. So the positive ion, the cation, comes first. Okay? With covalent compounds like phosphorus and chlorine, two nonmetals. Okay? The phosphorus comes first because it's more electronegative than the chlorine is. Does that make sense? But that's not always true. There are exceptions. Okay? One prominent example is a very common chemical. Okay, this is ammonia. We'll talk more about ammonia in this class here shortly. And ammonia, if we were writing it according to this rule, the hydrogen should be written before the nitrogen. It should be written H3N. But commonly we don't. We write the nitrogen first. Because somebody decided a long time ago that ammonia was in H3 and everybody kept doing it. Like lemmings running off the cliff, you know. It just happens. I mean, there wouldn't be anything wrong with writing H3N. It'd still be the same formula. Okay? But just commonly you don't see ammonia written in that fashion. Does that make sense? And there may be a better reason why that I'm not familiar with, okay? Could be.